Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. In the series of lectures on Indian astronomy, in this particular session, we will try to understand the phenomenon of rotation of Earth. Observing the sky has been a long-standing tradition in India. Sky is a very beautiful, vast and vibrant canvas one can look at. A lot of objects, lot of new events that happen on a very daily basis. We have seen in the introductory lecture that Indian astronomy is a body of science that helps understand Dig Desha Kala Jnanam, which means the primary objective of Indian astronomy is to ascertain the direction, the space and the time, Dig, Desha and Kala respectively. So, when we observe the sky, one among the common phenomenon which is unmissable and which happens very periodically is the sunrise and sunset. We are all taught in our schools that the sun rises in the east and sets in the west. For now, let us keep it that way. Have you ever wondered, is it only the sun that has this phenomenon? So, what about the stars that we see? Do they also rise and set? Have you all heard of constellations? The Great Bear, Orion. These are group of stars that they form a pattern. Have you watched them over the night sky? They change from one side to another. Have you seen the moon rise and set? Does the moon rise and set? We will try to understand what happens to these celestial objects, or rather, how do we observe the change and why do we observe that? We have also studied in our schools that the cause for the phenomenon of day and night is because the earth rotates on its own axis. If you see the animation over here, there is an imaginary line that is drawn between the top and the bottom of the earth, which is usually called the north and the south pole. So, the earth rotates in this particular imaginary axis and that is what causes the phenomenon of day and night. Let us try to understand this motion of rotation of the earth with an analogy by comparing it with that of the motion of a rotating chair, much like the one that I am sitting on. So, if you see this as the observational frame of reference, this is all I can see. So, if I am moving from my right to left very slowly, I can see, because when I am moving from my point of view, I am going to look very stationary. But I can slowly see the various objects that are present here, which are actually stationary, to be moving from my left to right. So, similarly, this is more of an anti-clockwise direction. If I do the same in the clockwise, for example, if I move from my left to right slowly, the same objects will look like they are moving from right to left, but they are actually being stationary here. So, as we can see, the movement of the objects which are stationary seem to be in the opposite direction of the motion of the observer. This has been beautifully captured in this verse written by the famous Indian astronomer Aryabhatta. The book is called as Aryabhatiya. It was written in 499 CE. Let's try to chant this verse. Anulomagatirnaustah pashyatyachalam vilomagam yadvat achalani bhani tadvat samapaschimagani lankayam udayastamaya nimittam nityam pravahena vayunakshiptah Lanka samapaschimagah bhapancharasagraho bhramati. Naustah, an observer sitting on a boat. Anulomagati, who is moving in forward direction. An observer sitting on a boat moving in the forward direction. Pashyati, sees. Achalam, stationary objects. Vilomagam, moving in backward direction. An observer sitting on a boat moving in forward direction, looks at the stationary objects to move in the backward direction. Similarly, Achalani Bhani, stationary stars are observed to move in west direction for an observer who is situated in Lanka. The Lanka here is a special point on the equator. It's not the Sri Lanka that we usually refer to. So, what is Aryabhatta saying here? An observer sitting on the boat moving in the forward direction looks at the stationary object to move in the backward direction. We should be able to read with this very easily. In all your train journeys, if you observe through the window, the stationary trees tend to move in the opposite direction. If your train is moving forward, the trees will be moving in the backward direction. Similarly, the stars, when the observer is situated on Lanka, are moving in the westward direction. The Lanka here, like we mentioned earlier, is a special point on the equator. We will talk about this in detail. The Lanka point, we will talk about it in detail in the coming slides. In the Indian tradition, we ascribe every aspect to a divine intelligence. In this case also, the earth's motion, the spin of the earth is ascribed to Pravaha, is deified as Pravaha. Pravaha is a Marut. So, this spinning motion is propelled by Pravaha. But at the same time, for an observer in Lanka, the whole of this Prapancha and all the Achalani stars, the stationary stars and the whole of the Prapancha moves in the westward direction while situated on the Lanka.
We all know that the sun rises in the east and sets in the west. Let us see this through a simulation. If I were to run and fast forward the time, we see that the sun slowly rises up, goes all the way to the zenith, and then in the evening sets in the west, and in the next day morning it again rises in the east, then sets in the west. We know this pretty sure, and every day we have witnessed this. Now, what we must also observe is that all the star lore, the entire hemisphere is rising and setting, and not just the sun. For that, let us again run the simulation and then observe the whole vast wide sky. We all well know that the sun is rising and setting, but if I were to keep looking at the east direction, you see that all the stars are also rising and setting. If you carefully observe, and if I remove the atmosphere, you will see that all the stars are also rising and setting, all the planets are also rising and setting. And if I were to look northwards, it almost looks like around the Polaris star, all the entire star lore is rotating westward. From east, they all rise, they all set in the west. Now, this shows us that the entire sphere, the celestial sphere, is rising and setting. This can be observed in this simulation. What's also very interesting is that if you look at the pole star seems to be up above the hemispherical line here, the line of sight that we have here. This is called the horizon. Above it is Polaris. My location is currently in a town called Parani in Bharat here. If I were to go to Pune at the same instant and locate myself, see the Polaris has shifted further up. Now, if I were to go somewhere up here in 49-degree north latitude, you will see that the Polaris is not here but way up there. Now imagine where would the Polaris be if I was on the North Pole, if I was on the very northern pole, and if I can go all the way, close to 90 degrees on the northern pole. Now, where is my Polaris? And where is the north here? Where is the south here? If I go and look at Polaris, Polaris is right on top of my head, and the entire asterism is just spinning around me. It's just spinning around me. If I fast forward the time, you see the Polaris is here, my horizon is here, and the entire asterism, the entire sky lore is spinning about this axis. Now, if I position myself exactly on the equator, and let's look at Polaris, you'll see that it's exactly on the horizon. And for someone in the equator, everything will rise in the east and set westward. For anyone on the point of the equator, the sky will rise perfectly in the east and set westward. Hence, from this, we understand that all the celestial objects are rising in the east and setting in the west. However, this visual of rising in the east and setting in the west works well only on locations of Earth closer to the equator. When you are close to the poles, the entire movement is quite different. Very interestingly, if I position myself back again, if I position myself back again on the North Pole and look at the sun, see the interesting motion of the sun. On the 18th of March, the sun throughout the day is just rotating around the horizon. And as time goes, slowly the sun is coming up on every day. You see, now on the 5th of April, the sun is rotating along the horizon in the northern pole. And slowly it comes all the way only up to a certain extent. It does not even come to our zenith. And this is why we have been learning that in the poles, 6 months are day and 6 months are night. Hence, the position on the earth from where we observe the sky changes, and the rotation of the earth along the north south axis makes the entire star lore rise and set.
So this is why Aryabhatta said that when we situate ourselves on equator on the special point called as Lanka, all the celestial phenomena will exactly move towards the west. Let's quickly summarize what we have seen till now. So we saw that the earth rotates on an imaginary line called as its axis, and the points the axis meets the earth in the northern and the southern side are called as the geographical north and south poles. At the same time, the rotation of the earth gives us our directional system, which is called as the east, west, north and the south cardinal directions. When we say north, we generally refer to the direction of the north pole, while we say south, it is the south pole that we refer to. We also saw that the earth definitely is rotating from west to east, which is why the sun is appearing to raise from east to west. Why? We saw it with the analogy earlier, and we also saw in the simulation the analogy of the rotating chair. When I am moving from right to left, all the things that are placed stationary were moving from left to right. Understanding the earth's rotation and its axis help us understand why we have a directional system in place. Let us now try to learn the names of the directional system in Indian astronomy. North is called as Uttara or Udichi. East is called as Purva or Prachi. West is called as Paschima, Pratichi or Apara. South is called as Dakshina, Avachi. The intercardinal directions, which are between the two cardinal directions, they are also having a specific naming. Northeast is called as Ishanya. Southeast is called as Agneya. Southwest is called as Vayavya. Northwest is called as Naitritya. Let us now try to understand the names that are related with the positioning on earth. What are all the terms that we usually use to position ourselves on the earth? There is an equator, there is a latitude and there is a longitude. Similarly, in the Indian system, the equator is called as Bhumatya Rekha. So, the latitude is called as Aksha and the longitude is called as Deshantara. Now, let us talk about the Indian system of positional reference. How do we calculate time these days? We have something called as the Greenwich Meridian, GMT, a meridian that passes through a location called Greenwich, situated in United Kingdom. India is considered as 5.5 hours ahead of GMT. Using that only we calculate our current day's time. But in those days, in the Indian astronomical tradition, Ujjain held a special place. So, the meridian that passes through Ujjain is taken for calculating time. The meridian especially which passes through Ujjain and the point where the meridian meets the equator is what is referred to as Lanka. Due to an Eurocentric approach to life and a lot of other things, we have started to shift to Greenwich Meridian. Even in current days, a few modern astronomical works use the Ujjain Meridian as reference. So, this point Lanka is also otherwise called as the 0 point from which measurements were taken. So, it is important to understand such sophisticated system of Aksha and Deshantara, which is latitude and longitude, have already been present in our Indian astronomy. Using this only, our civilization was able to progress in shipbuilding and a lot of other activities. So, now let us move on to the observer's point of view. The sky is observed as this visible dome because beneath that the earth will be there. So, this is the visible dome that is available for us to observe all the celestial phenomena. 2 points that are of use is the zenith, which is the exact top point, which is otherwise called as Khamadya, and the horizon, which is called as Kshitija. We have seen that all of the celestial phenomena, for example, the sun rays or the moon rays, all of that happens from east to west because the earth moves along the west to east direction. Similarly, we were seeing that when we place ourselves in different locations of the earth, the way we see this visible dome will be completely different. So, what will happen if we situated ourselves in the North Pole? What will happen to the pole star? It will be right above the head in the zenith or Khamadya. And when we start moving towards the south, towards the equator, the pole star will also start shifting in the opposite direction. And when we reach the equator, it will be right in the horizon or Kshitija. Do you now see what level of detailing has gone into calculation of such astronomical? You can understand that when I am on the North Pole, I am at 90° north latitude and the pole star is right above my head. When I move towards south by 10 degrees, the pole star moves in the opposite direction by the same 10 degrees. When I move further south by 45 degrees, the same happens to the pole star 45 degrees on the other side. When I move to the equator, the pole star would have by then touched the horizon. Similarly, thus, by understanding the position of the pole star, I will be able to locate myself latitudinally on earth. Thus, such celestial events help us to map our position on the earth. Thus, by observing the sky, I will be able to position myself on the earth. We will unravel more such interesting concepts of Indian astronomy in the upcoming lectures. Thank you.